We are into our last couple of types of factoring here, and I think we will break this video into two. There's two types of factoring when it comes to binomials. That's polynomials with two terms. We've been factoring polynomials based on how many terms they have, and here is a little bit of a summary of what we've done so far. We factored by GCF. You should always do that first. We factored polynomials with four terms next. We did that by grouping. Then we factored three terms, quadratic style polynomials, using the star method. And now we need to focus on polynomials that have two terms. And first we're going to look at difference of squares. This tends to be the easiest type of factoring as long as it falls into this category. All right, you notice with the category, the name of it is difference of squares. There's sort of two things there. It has to be a difference. That means it has to be a subtraction there. This type of factoring does not work when there's a plus sign instead of a minus sign. And they also have to be perfect squares. So for example, x squared is x times x. 36 is 6 times 6. We need things that are perfect squares like 49, 64. I have a list of those perfect squares here for you. If you want to take a glance, pause the video and look. These are the types of numbers that we're looking for. Perfect squares, and things like x squared or x to the fourth or x to the sixth or y to the eighth or y squared. Things like that, even powers. All right, here is how we're going to factor those. Anytime we have a difference of squares, notice that this is a difference and it is two perfect squares, it's always going to factor into this type of thing. It's two binomials. It's the square root of the first and the square root of the second. Notice the only thing different between the two parentheses is one of them has a plus and one of them has a minus, and it does not matter what order you put those in. You could put the minus first and the plus second, or the plus first and the minus second. I tend to go with the minus first because that's what the problem gives you. Let's look at a few examples of this. If I wanted to factor y squared minus 25, for example, that's the same thing as the square root of y squared. Since y squared is y times y, I'm going to put y in the first slot. I'm keeping it in the same order that I have it in the problem. Minus 25 is the same as 5 times 5. So 5 will go into the second slot. My first factor is y minus 5. My second factor must be y plus 5. It's two of the same thing, just different signs in the middle. They are conjugates. We talked about when multiplying polynomials, when you multiply conjugates, the middle term eliminates. That was a couple of lessons ago. If you want to go through and distribute this and make sure that that happens, you can. All right, let's try another here. Let's try B. 49s squared minus 4t to the fourth. I'm thinking, what number is going to go in the first blank here? I need two of the same thing that multiply to 49s squared. Well, 7 times 7 is 49, and s times s is s squared. And now, remember, one will have a minus and one will have a plus. What two things will multiply to give you 4t to the fourth? Well, 2 times 2 is 4. T squared and t squared will give you t to the fourth. So that is the factored form of that difference of squares. Notice on this next one that it does not look like a difference of squares, right? 18 is not 9 times 9. Z is not z times z. It doesn't look like a difference of squares. If we go back to our factoring chart, remember that the first thing we always need to look at is, can we take out a GCF? If you could take out a GCF, you should absolutely do that first. All right, here's our example again. So looking at this example, is there a GCF? It turns out there is. We could take a 2 and a z out of everything. If you need to go back and refresh how to take out a GCF, that was a video called Factoring, GCF and Grouping. When you take a 2z out, you're left with 9w squared minus 1. And notice that now what we're left with is a difference of squares. So I'm going to keep the 2z. That's going to remain a part of my answer. And now I'm going to break apart the 9w squared minus 1. What times what equals 9w squared? I need the same thing in both slots. 3w and 3w make 9w squared. I know I'll have one with a minus and one with a plus. And wouldn't you know it, 1 times 1 is 1. And so there's my final answer. Notice that this one took a couple of steps, right? We had to factor a GCF out first, and then what we had was a difference of squares. You can combine, I have not said this, but you can combine any number of these, right? You could do GCF and difference of squares. You could do difference of squares and then grouping. You could do grouping and then difference of squares, or star method and then difference of squares. You can combine them in any way. Here are some more examples. I'll let you try these. You should pause the video and try each of these. The first, a squared minus 64, should break into a minus 8 and a plus 8. The second one, 5q and 5q multiplied to 25q squared, 7w and 7w multiplied to 49w squared. And the last one down here, those don't look like perfect squares. But if you divide the 98 and the 50 both by 2, you end up with 49 and 25. That's perfect squares. Notice they also have an m and an n in common. So the first thing is to factor out this GCF. This right here, the 2mn, is a GCF. All right, the thing that I have underlined in purple now is a difference of squares. So we can break it apart into 7m minus 5 and 7m plus 5. Notice that our final answer is this whole thing. It's not just the broken down part from the difference of squares. It's the GCF and the difference of squares pieces. All right, remember from the beginning, p squared minus 9, easy. That's p minus 3 and p plus 3. This, I said at the beginning, there's two things that we have to have. We have to have a difference and they have to be perfect squares. Since this one is a plus, it's not a difference, this we're just going to call it prime. This difference of squares method only works when we're starting with a subtraction problem. Remember from the word problems lesson that subtraction is the key word difference. When you read difference in a problem, it means you're doing subtraction. All right, a couple more. W to the fourth minus 81. We may have some extra work to do here. When you get to the end of any problem, you should ask yourself if you're done. So for this first problem here, w to the fourth minus 81. Looks like a difference of squares. Let's try it by difference of squares. W squared and w squared makes w to the fourth. 9 and 9 makes 81. Look at this here. That's another difference of squares. W minus 3, w plus 3. How about this piece? Is this a difference of squares? It is not. It's a sum. It's not a difference. So we can't break it down. It's just prime. And there's our final answer. Pause the video and try the one below. Should work about the same. We have a difference of squares, breaking it into y squared minus 1 and y squared plus 1. The y squared minus 1 is another difference of squares, so we can break it apart one more time. It breaks into those two. The y squared plus 1 is prime. So this entire thing is our final answer. All right, last two for this video. The top. So what we'll do for every problem from now on, what we're going to do is we're going to look at it and say, first, can we take out a GCF? This problem looks like we cannot take out a GCF. Then we're going to categorize it based on how many terms we have. There are 4 terms. And so based on the chart, that says we need to do grouping. So if I'll group the blue and the purple here and do a GCF for each. Y squared out of the first group gives you y minus 5. Again, please go back and review any of these videos that you feel that you need to. The purple group, 4 is a GCF, and I'm taking out a negative 4. And notice that the y minus 5 is in common in both, so I can take y minus 5 out of each and have left y squared minus 4. But wait, that's a difference of squares. So now we've done grouping, and now difference of squares tells us that y squared minus 4 is y minus 2 and y plus 2. And that is my final answer. Again, for every step that you do, you want to just double check and make sure there's nothing else that you can do to break it down any further. Once you get down to linear factors, that means that the highest exponent of any of these factors is a 1, then you know that you're done for sure. Sometimes there's not a way to get them down to linear factors, right? So each of these, the exponent is 1. That's great. But back on these, notice that this was not a linear factor. The others were linear factors. Sometimes you just can't, but you're attempting to get them all down to linear factors. Again, pause the video, last one of this lesson. 4 terms, I would start by grouping. Then the p plus 7 is in common. The part that I've underlined in yellow is a difference of squares. And that is factoring difference of squares. I'm going to do an entirely separate video. There is one more method that we're going to use for factoring things with 2 terms. and it's when you have cubes instead of squares. I'm going to put that in a separate video.